Hello and welcome to the video. This video is going to be a revision for you. In this video, I'm going to discuss resolving vector and then how to add vector to find the resultant vector. The resultant vector is basically the result of the sum of the vectors. We'll go to the our simulation here. So the first thing that you need to have is a Cartesian. So the Cartesian's axes help us to visualize the vector better. So first I'm going to bring the vector up. All right, let's say we have a vector A. So I'm going to uncheck this box here first. Okay, so we have a vector A. So vector A is a vector that is pointing on the x-axis, and it's only have horizontal length. So this kind of vector is called one-dimensional vector. So the same goes if you have a vector that is only pointing in the y direction. This is all dimensional vector. So if you want to add one-dimensional vector, so let's say you have vector A that is pointing in the x direction and has a length of 17 meter. So and then we add another vector. We have another vector, vector B, and vector B is pointing to the left and has a length of 15. Let's say this is displacement. So the length is 15 meter, for example. So the sum or the resultant of A plus B is just, I'm going to check on the sum box here. So if you bring the sum here, you will see that the sum is 2, S stands for the sum. Alright, so the sum or the resultant is 2. So you have positive 17 to the right and negative 15 to the left. So the sum is positive 2. Alright, so if you look at the arrow is pointing to the right because the positive vector, the magnitude of the positive vector is bigger than the negative vector. So the resultant is going to point in the direction of the positive vector. Alright, same goes for if you have the vector in the y-axis. So let's say the length is 15 and vector B is 8. Alright, so 15 plus with negative 8. So the sum is when we add the vector. So that's why I'm saying plus. So 15 plus with negative 8, you get 7. Alright, and 7, and the vector is pointing upwards. And the direction of vector either 90 degree to the horizontal, as you can see here. The vector sum or the resultant vector is 90 degree to the horizontal, or you can describe the vector as a resultant vector that is pointing to the positive y-axis. Okay, now I want you to watch very closely what happens if I move one of the vector to the x-axis. I want you to look at the resultant vector. Alright, so the resultant vector is just the sum of vector A plus vector B. So now currently the vector S is at 90 degrees to the horizontal and pointing in the positive y-axis. Alright, so if I move vector B to point to the positive x-axis, alright, can you see the transition there? So now it is here, and then if I move the vector B to the x, so as you can see the resultant vector has changed. Alright, so if you look at the resultant vector has a horizontal component of 15, which is the length of B, and then it has a vertical component of 15, which is the length of A. So the resultant vector of A plus B is 15x plus with 15y. Alright, and then the magnitude of the resultant vector is 21.2, which is the length of the hypotenuse. So when you add two vectors that are perpendicular, the result of the addition or the result of the sum is going to be a vector that has a length of 21.2, and currently it is pointing at 45 degree from the horizontal. So this is the vector A plus B. So this is also how you break up a vector. Alright. Just now we add two perpendicular vector and then to form this diagonal vector. Alright. So we combine two perpendicular vector to form one diagonal vector. So resolving vector is a reverse process of combining two perpendicular vector. Resolving vector is when we take a diagonal vector such as this one, alright, and then we break it up into two perpendicular vector. Alright, so if I move the resultant vector and then I overlap the resultant vector here, you can see that it is actually the same thing. Alright, so the resultant vector is the sum of vector B with vector A. So I move, this is vector A on the left of the sum of the diagonal vector. So if I move it here, so they are going to have the same length, see, there. Alright, so that is what we are doing there is we combine vector A with vector B. Okay, so let's say I'm going to add another vector. So I'm going to move vector A down here. So it still have the same length, 15, and then vector B down here. Alright, so the sum of these two vectors is the vector in the blue. I think I'm going to move it here. So we have these two vectors, and then I'm going to add another vector. So vector C, I'm going to put the vector C, I'm going to move it until it has the, okay. Now, okay, don't look at the sum. So I'm going to remove the sum first, okay. So as you can see here, the length of vector C, alright, so I moved vector C so that the length is 21.2 and the angle is 45 degree. If you look at vector C has a length of 21.2 and then the direction of vector C is 45 degree. So to resolve vector C means that you are going to break the vector C into its perpendicular component. Okay, right. So what I'm trying to show you here, remember from our previous examples where we add to vector A and vector B that are perpendicular to one another. So basically in resolving vectors, we reverse the process. Instead of combining two vector to form the diagonal vector, we break up the diagonal vector into its horizontal and vertical vector. So if I take vector B here and I put it here, so as you can see, vector C is actually a combination of vector B and vector A. Alright, so I repeat it again. Resolving vector is breaking up the vector into its horizontal and vertical vector. Alright, so if you add the horizontal, alright, this is the horizontal. If you add back the horizontal component of the vector with the vertical component of the vector, you will get back the diagonal vector. So this is when you combine. Alright, resolving means you break up vector C into its horizontal vector and vertical vector. So that is resolving. The way we do it is by the Sohcahtoa rules. So if you want to find the magnitude of the horizontal, you can use cos. So cos of 45 is the horizontal component over the hypotenuse, and then from there you can get the value of the horizontal component. Alright, so if I change, let me remove this vector. Alright, so I hope from here you can see vector C is broken up into 15x plus 15y. So a vector of 15x and a vector of 15y will make up vector C. So if vector C is pointing in a different direction, then its horizontal component becomes negative 14 and its vertical component is 9. So the the component, the angle will change with the vector. Alright, so that is resolving vector. You need to be able to do resolving vector to solve problem in chapter 2 especially, and also in chapter 3, where you have to resolve vector velocity into x and y component. So we are going to use it in chapter 2 and chapter 3. Okay, so I'm going to continue with vector addition. So I'm going to remove vector C. Okay, now I'm going to add back vector A. So let's say we have vector A here. So vector A, as you can see, vector A has a magnitude of 21.2. The direction of vector A is 45 degrees from horizontal. It has a horizontal component of 15x, a vertical component of 15y. Alright, so let's say you have another vector, vector B. So I'm going to put it there. So I'm going to add another vector to the Cartesian. So I'm going to put it there. So it has negative 12x and positive 8y. To make it easier for us to see the vector, I'm going to move the vector, the tail of the vector to the origin. Alright, so the origin is the coordinate 0, 0. So the length of vector 12, I know that is going to end here at negative 12 scale here. So it is very useful, and we are going to use it a lot when drawing the free body diagram, the force diagram that will represent all the forces that acting on the object. So the way we do it is we put all the vector forces, the tail of the vector forces, at the origin of the Cartesian. Okay, now we have two vectors, A and B. So I'm going to make the vector B like that. Okay, so how do we add vector A with vector B? I'm going to bring in the sum of the vectors. So if I click on the sum here, so it gives me the sum. So if you look at the sum, look at the x-axis of the resultant. So this is the resultant vector. So the x-axis is basically the sum of the horizontal component of the two vectors. So 15 plus with negative 10, so you get positive 5. So remember, 15 plus with negative 10, you get positive 5. Alright. So the way we add vector is, first we add the horizontal component of the vectors. Alright, and then we look at the vertical. On the vertical of A we have 15, and then vertical of B we also have 15. So 15 plus with 15 we have 30. So the magnitude of the resultant vector is just 5 square plus with 30 square, and then square root all, you get 13.4. So this vector is the sum of vector A plus with vector B. You get this vector S with a length of 13.4 and a direction of 18.5. Let's say we add another vector, and then I'm going to make it so that the vector C here will only affect the vertical height of the resultant vector. So if I change the length, you can see that only the vertical height of the resultant vector is changing. Because we add another vector to the diagram, it changed our resultant vector. Alright, so previously we have 15 plus 15. So we have a total length of 30 in the vertical axis. Now because I add another vector C that is pointing downwards, so as you can see, the length of the vertical now has changed to 20. Alright, so if I increase, it will keep decreasing. Alright, so because now we have 30, 15 plus 15 minus with 13. Alright, so if vector C is also two-dimensional, let's say it's point that way. Alright, let me make it bigger. Okay, so now if you look at our resultant, both the horizontal and vertical component has changed. we have negative 10 here, so the negative 10 comes from 15 plus with negative 15 from B, and then you have to add with negative 10 from C, so you get negative 10. The horizontal component becomes negative 10. So, and then the vertical component of the sum is 15 plus with positive 15 plus with negative 10. So you will end up with 20. Alright. So the angle of the vector now is 180 is tangent, shift tangent of the y-axis is 20. The x-axis is 10. Alright, you can ignore the negative because now we're just looking for the direction of the vector. So you will get the direction of the vector is 63.43 degree above negative x-axis. Okay, so because this is the negative x-axis, so if we bring this sum to the origin, okay, we move our vector A to the side so that we can so that it is easier to see the vector S. So we move it out. So we move it out. We move it here. All right. Okay. So the sum of A plus with B plus with C. So we are going to have negative 10x plus with 20y. So the resultant vector has a magnitude of 22.5, all right, sorry, 22.4, and then the direction of the vector is 63.43 above negative x-axis, or 116.6 from positive x-axis, either one. Okay, but normally we use the angle between the vector to the x-axis, so in this case from the negative x-axis. So that is how you do resolving vector, the idea of resolving vector, and then from there we apply the concept of resolving into vector addition, and we are going to use these two concepts a lot in physics, starting from chapter 2 until probably chapter 6. We are going to be dealing a lot with vector quantity. You need to be comfortable with resolving vector, with the negative sign of the vector, and then also how to add vectors. If you have more than one vector, how do you add the vectors and find the resultant vector? Alright, so like the resultant vector is the blue vector here, so you need to find the magnitude of the resultant vector, and then you need to find the direction of the resultant vector by adding all the vector here. I think that is it for this video. I hope it helps. If you have anything, you can ask me during our Google Meet session. Thank you very much.